Welcome back everyone, and we're going to continue Polynomials Class 9 Part 2. In the last video, we stopped till remainder theorem and we were about to continue learning a remainder theorem. Now let's get going. Now, this is a very short intro, leave it, okay? Please don't mind about that. If you want to learn all the basics before you delve into the remainder theorem, please don't forget to check out my first video, okay? I'll try to post it in the description and give some detail about that, but we'll see about that in the end. Now, a remainder theorem. If we consider two numbers, let's say 15 and 6. Now, you know that when you divide 15 by 6, we get quotient as 2 and the remainder as 3. Okay, so this is how we express it. Now, in the book, they're just asking how it is expressed, and this is how it is expressed as 15 equals 6 times 2 plus 3. It's just that you have to cross multiply 6, and then you'll get like 6 times 2 plus 3. That's the same thing here. Okay, now we observe that the remainder 3 is less than the divisor 6. So that's quite obvious, I think. Yeah, okay. So what is the divisor? This is the divisor, and this is greater than 3. Okay, that's quite obvious. Okay, leave it. Now, if we divide 12 by 6, we exactly get 0. So the remainder is 0 and your quotient will be 2. So if the remainder is 0, we can say that 6 is a factor of 12, or 12 is a multiple of 6. So only if you get a remainder 0, you can say that it is a factor or a multiple of 12, or 12 is a multiple of 6. Okay, that's quite obvious. We would have learned it in our 4th or 5th grades. Okay, now this is all common. This is the, let's say, dividend. I don't even have to write this, okay? But for those of you who would find it more convenient, I will write it, okay? Now, what is the symbol? Why am I writing equal to? I'm just not very experienced. Okay, plus remainder. Okay, so the dividend is equal to the divisor into quotient plus remainder. That's just, you get this 6 to. Okay, now this is the divisor quotient, and this is so obvious. Wait, just a small trick. I will show you just a small trick. Okay, I'm just labeling that so you can visualize it better. And this is the dividend. Now this would be very obvious: divisor times quotient plus remainder. For those of you who don't know this trick, so divisor into quotient plus remainder, that's the same thing. Okay, we did here. Okay, divisor into quotient plus remainder. Okay, and this method, this also shows that this is how you will get let's say if you want a mixed fraction, you will write, I think, 6 2 by 1. No, that's not how you write. I'm not sure. Leave it, forget that thing. I didn't recollect those are all very basic, but I just don't give much importance to that. Okay, now we all know to divide like this. Okay, this is very obvious, and this I just wrote that divisor equal to dividend times quotient plus reminder that is called the Euclid's division lemma. Okay, or yeah, pretty much that's it. That would be, you would learn that in 10th grade. It will be in the first chapter. Now let's come back. We were seeing with numbers. Can we do that for polynomials? Okay, can you divide this polynomial by x? Okay, for that I think you knowing what is a monomial, binomial, trinomial, that would be better. But let me just say, monomial means it will have only one term. This is a monomial. Now if there are two terms, it's a binomial. And guess how many, what would you call when expression has three terms? A trinomial. Okay, trinomial. Okay, it's just for extra resolution for your brain. Alright, now let's not consider this example. I'll just go straight into how you will divide any polynomial. Okay, for example, okay, after I explain this, I'll explain this process fully. Okay, and then I'll walk you back, okay, so that you'll get a clear understanding. Okay, I'm teaching, this is CBSE, but I'm teaching like matriculation, because if you really want to be sure that you are taught what you are taught, following the NCRT is the only solution. And I think this is more feasible. Yeah, I'm quite lazy to take those videos. I'm not doing this for views or anything. It's just to I want to make myself good in this topic, so I'm just teaching. Well, you would also benefit from that, right? Okay, let's get into the topic now. Let's take the numbers. Okay, why am I going there? Okay, now if I divide this polynomial, now tell me, is this a polynomial or is this an algebraic expression? Well, whatever it is obviously an algebraic expression. How do you recognize that it's a polynomial? Because it has the whole number as its exponent. Okay, here 1 and here x power 0. Okay, but we're just not mentioning that because that's very obvious. Okay, now this would be your dividend by your divisor. Alright, okay, wait a minute. Okay, now if you can do this thing, this whole process, it's called the division algorithm. Okay, now this is exactly the same as how you would divide a number. Now okay, I'll do it here. You are taking 3x power 4 minus, no, there space would not be enough. Okay, x minus 1. Okay, now here I want to consider the first term. It's 3x power 4 and the first term of the divisor, that's x. Now with what number should I multiply with x to get 3x power 4? What is it? Okay, now x times 3x power 3 would give me 3x power 4. Am I correct? So I will write 3x cube. Okay, because x times 3x cube will give me 3x power 4. That's just what I said. Okay. Now I'm writing 3x power 4. The blue color should have been red color. Just that's the exception here in my color coding. And now we are not multiplying the whole term with x alone. We have 1 also. So we just multiply this 1 with this. Okay. So now minus 1 times 3x cubed would be minus 3x cubed. Okay. Now remember, we are subtracting. That's very important. Okay. Now 3x power 4 minus, you're gonna multiply it inside the distributive property. All right, so minus 3x power 4, this would be cancelled. I mean, that will result in 0. Now minus times minus, that's gonna result in a plus. Okay, now plus 4x cubed, no, minus 4x cubed plus 3x cubed, that would give you negative x cubed. Okay, and then you write the remaining terms just down as it is. Okay, now you are going to treat this as a whole new term. You're gonna forget everything about this. You're gonna forget that. Okay, you don't want to look back. Okay, you got what you want from that first part. Okay, so when you treat this, whatever this equation in black, okay, now you're treating that as your new dividend. Okay, now again I had to consider this. Now with what number do I have to multiply x to get this term? Negative x square, right? So negative x square times x would give me negative x cube. Okay, and if there's no coefficient, it's obviously 1. And then we don't want to forget that we have this term also. Okay, okay, now my thing is getting too shabby. Okay, now minus 1 times minus x squared, that would be plus minus, note these signs, minus and minus. Okay, so it will be plus x squared. Okay, now remember this is in minus, so minus times minus, that's gonna give you a plus. Okay, so minus 1 cube plus 1, they're gonna cancel, and then you don't match, this don't match. Okay, so you're gonna write the same term. You're gonna bring this 3 entirely down. So what you get, minus, so minus into plus, it's minus. Okay, it's minus, so it's minus x square, and what is here, minus 3x, right? So I'm gonna write minus 3x, and I'm gonna bring that minus 1 down. Okay, so minus 1. Now if this looks very shabby, you can refer this. Okay, okay, now this is our new dividend. Now we have to forget about this entirely. We consider this as our new dividend. All right, so now with what number again? Okay, this is getting too shabby. Let me clear this, give me a sec. All right, it's somewhat better. Now I have to consider the first term. With what number do I have to multiply x so that it will give me negative x square? Obviously negative x, because x times negative x gives me negative x square. Okay, so I am adding another term, minus x. So minus x square, and remember we have the other term negative 1, so negative 1 times negative x would be positive x. And now you're gonna cancel. So and again, don't forget you have this sign, okay? You're subtracting. So now when you use the distributive property, you're gonna get a plus, and then here you're gonna get a minus. All right, okay. Now what color shall we use? Let's use red this time. Minus x squared plus x squared, that's gonna be cancelled. Plus 3 minus x, it's gonna be minus 4x minus 1. Look, we're almost at the end. Okay, now with what number? Again, this is our new dividend and the same divisor. Alright, now with what number do I have to multiply x to get minus 4? Just minus 4, because x times minus 4 will give me minus 4x. So I'm gonna multiply, and now what do I get? I get minus 4, and minus 1 times minus 4, because we can't leave this and this, okay? So we get plus 4. Again, we're subtracting, and after you multiply, you're gonna get plus inside, okay? And then here to inside, you're gonna get a minus. Okay, let me just remove that clearly. Oh, look, some. Okay, now what I'm going to get is that minus 4 plus 4 will be cancelled, minus 1 and minus 4 is going to give me minus 5. There you go. That's all. This is how you divide a polynomial by another polynomial. Okay, that's all there is to it. Now since you understood this, okay, let me clear it first of all, because I would need for referencing, and I'm not doing this for views, so I would also expect some comfortable sense. Okay, I'm not gonna do so favorably. Okay, I don't think you understood what I said, but forget that. Let's go on to the topic now. We have to look at this. Now, the first step 1, step 2, step 3, step 4, step 5, step 6. Okay, I expect you to read this fully and you would get an idea. Okay, or else you don't have to read. If you're struggling to read, you could just use the explanation which I gave you. Okay, now what did we finally get? This before that, okay, we considered, okay, this was our initial, okay, why black? It's already in black. I'll do a contrasting color. So 3x squared plus x would be our dividend. This is our divisor. See, Euclid's division lemma is unfolding right now. Just this, have a look at that while I write these terms. Okay, I think you would have identified this by now. Now let's see the dividend. Okay, this thing is here, that thing is just this. The divisor, let's do another color. the divisor. Okay, that's this and that's this, and the quotient that's this and that's just this. And how about a new color? And the remainder, that is this. Okay, so what have we concluded? We found that the dividend is equal to divisor into quotient plus remainder for a polynomial too. There is simply no difference. Okay, so in general, let me clear this out. This might be too colorful and distracting maybe. Okay, there we go. This taskbar keeps on changing. What an inconvenience. Okay, where was I? In general, if p of x, okay, this is p of x and this is g of x, this is q of x, and this is r of x. Okay, so if the polynomial in the variable x and the dividend in the variable x are two polynomials such that the degree of p of x is greater than or equal to, see, 2 is greater than the degree, both its degree are 1 and 0. Okay, so it's 2, so it's obviously greater. Only if the dividend, that is p of x, if that is greater, then only this whole division can be carried out, or else it will not. Alright, now if so, then we can find polynomials p of q and q of x and r of x, that is this and this, such that p of x equals g of x times q of x plus r of x. Okay, this is the general formula. You don't have to memorize it, but if you just understand, that's all. Okay, now where r of x, that is this, okay, is less than the degree of g of x, so 1 is less than x plus, is it x plus, yeah, it's x plus 1. Okay, so its degree is 0. If it's a polynomial, it always should have a variable, alright? So if it has a variable, that variable is x and that variable is in the power 0, so that degree is less than its degree, that is 1. Okay, then if it satisfies all these conditions, let me underline that. Okay, all these conditions, then we can say that p of x divided by g of x gives q of x as quotient and r of x as remainder. There's nothing, literally there's nothing in this paragraph. Nothing, it's just explaining this. Okay, this division is the fundamental stuff. Okay, now let's move on. Now let me show you a trick. Instead of doing, let me clear all this, it looks quite messy. There we go. Now instead of doing this a long horrendous process all the way from top to bottom, this is quite a chore. Okay, suppose we just want to know the remainder. How will you do it? Okay, there's a trick. Consider this polynomial, that is p of x. This, if we replace x by -1, how can we just do that? Look, the divisor x plus 1 equal to 0, then x equal to -1. Okay, That's why we are replacing it by -1. So wherever there is x, you replace it, okay, with a -1, and then you obtain the remainder. Okay, this is the remainder. Look, the same remainder. Instead of doing this huge task, you just substitute the value of x you find the value of x using your divisor. That is, if x plus 1, then you get x equals -1. With that, you substitute for this, and there you go, you get your remainder. Instead of without doing any of that, you don't have to do any of this work. That is not necessary for finding the remainder. If you want to find other stuff like the quotient, you might want to do the actual division. That is the remainder theorem. Okay, you just substitute the value of x in the polynomial and the result is your remainder. That's all there is to it. Okay, that's literally all there is to it. Okay, so that's what they're saying. Look, consider x cubed. Consider another example. Okay, now the root of x, that is root, what did I say in the previous session? A root is also known as a 0. So putting equal to 0 is obvious. Alright, so x plus 1 equals 0, x equal to -1. That is obvious. Now when you substitute, you get 0. So 0 is your remainder when you divide this, okay, by this. So doing this is equal to the remainder obtained by actual division. Okay, note that you don't have to highlight, but I'm highlighting this so that you clearly understand what I mean. Okay, now is it not simple? Is it not a simple way to find the remainder obtained on dividing a polynomial by a linear polynomial? Okay, so rather than doing all this long division, it is simple to find the remainder by dividing using a linear polynomial. So we are going to generate this in the form of a theorem, and that is in the form of the following theorem, and that is the remainder theorem. And we will also be proving why this theorem is true, giving us a proper proof of this theorem. My underlining is so bad here. Excuse me for that. Let me give it properly. Even here it's messy. Okay, whatever. Now let's get into the remainder theorem. Okay, let's use a very important color, a royal color, for royal important stuff. Remainder theorem. Oh, this is quite blue. It's okay. Now, if p of x is any polynomial, okay, let's consider these. Using these variables might complicate. So, if let's say p of x, let's use the same example. Okay, we'll use the same example: 3x power 4 minus 4x cubed minus 3x minus 1. 3x, where was I? Right here. 3x cubed minus 4x minus 3x minus 1. That is p of x, okay, divided by any real number. If p of x is divided by the linear polynomial x minus a, in the sense that is divided by x minus a. Now they're also saying that the degree is greater than or equal to this. Okay, that's what they mean. And let a be any real number. Okay, a be any real number. Okay, we're given this is the value and this is the value. All right, now let's delve into the proof. Let p of x be any polynomial with degree greater than or equal to 1. Okay, it's greater than 1 obviously here. So suppose when p of x is divided by x minus a, the quotient is q of x. What was the quotient? Remember, I think it was, let's see, where was it? 3, this is the equation, 3x cubed minus x squared minus x minus 1, 3x squared, is it? 3x squared minus, what is it? Minus x cubed, yeah. It's x cubed minus x minus 4, that is the quotient, plus the remainder, it's minus 5. And let me do it in another color. This is the remainder. This, oh, wait a minute. This is the remainder. Okay. Now. So, this is, what is this? This is the general thing, okay? Now, if x minus a, if x equal to a, here in the sense x plus 1, okay, equals x minus 1. But if x equal to this, then here if in x value we're substituting a, okay, and a minus a, you're gonna get 0, and 0 times anything is gonna be 0. So this obviously gonna become 0. 0 plus r, you get r, and that's what they have given. Okay, the proof might be, you might not understand, and those of you who understand, okay, well, great job. But if you haven't, or if you couldn't understand, I suggest you to check Khan Academy. Okay, so you just go to Khan Academy here. Okay, wait a minute, my connection's poor, I think. And you go to class 9. Go to polynomials. And a remainder theorem.
Is this to figure out the
They're gonna teach you the division algorithm, which
is
I
going
taught,
to be
and then f of x and all the above things, and then you should do the remainder theorem checking factors. This too, okay. These
is
two
the
videos
expression x minus
so you just gotta download it, okay. All the chapters will be here, but you can also do practice. It's completely free. It's kind of charity for those who are unable to access better facilities, okay. Well, don't take me wrong, I don't know, poor choice of words, not poor facilities, but if you want, you could use this, okay. It's completely free. And if somehow you're not able to get into this by some reason, it's available in YouTube. You just type Khan Academy Class 9 Polynomials Remainder Theorem, and you will get, with the proof, you'll understand that way better. Where was I? Okay. Now, example 9 and 10 are just a few other examples, okay? Let's delve in. Okay, example 9. Find the remainder when this polynomial is divided by this polynomial. Now, what have I taught you? This is your divisor. So, if x minus 1 equal to 0, then x equal to 1. So, when you substitute x, the value of x here, you're substituting, and the value you get is your remainder. When you do that long division, your remainder, whatever you're doing here, your remainder will be 2, and that is this, okay. So this is how you would, this is a shortcut for finding the remainder alone, okay. And example 10 is quite a good example, okay. Now let's consider this polynomial, okay. Now when you substitute, you're gonna get t equal to minus 1 by 2, and when you're substituting, you're getting a 0. Note, you get 0 as the remainder. And if 12 by 6, it's gonna give you 2, okay, plus 0. Your remainder is 0. That means 6 is a factor of 12, and 12 is a multiple of 6, okay. And if you get the remainder 0 in factor theorem, if you get the remainder as 0, in a remainder theorem, that is called factor theorem. That's all there is to factor theorem. If the remainder is 0, you can be assured that your dividend and divisor are multiples and factors of each other respectively. Okay, that's it. So now if you intently look at this, you're gonna get a 0. That's what they're saying. Let us look at the situation of example 10 more closely. My underlining, it never gets proper. Okay, and this 2t plus 1 is a factor of q of t. Okay, because it's equal to 0. Okay, this is a particular case of the following theorem, and the following theorem is this. Now again, this explanation, if you're not this proof, this proof, I don't think it's given in Khan Academy, so I'll, if so, search that, and if you find, good luck. Now anyways, I'll still be teaching this to you. Now the proof by remainder theorem, this is what we found. And if a equal to 0, okay, then x minus a is a factor. So well, I don't think you would need this. Okay, wait, give me a moment. Alright, now let's do from the beginning. I thought by just saying the proof you would understand. I realize a lot. Okay, if p of x is a polynomial of degree greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x. If p of a is equal to 0, and if p of a is equal to 0, x minus a is a factor. It's very obvious. Okay, there you go. So you just wait. This thing, 1 minute, looks like some error happened in my device. It's not an error, it's just my hand moving somewhere. Okay, now what they are saying, what this statement actually says. What does this statement actually imply? If x minus a, let's, in the previous example, x minus 1, it was x plus 1. Okay, if this is a factor of, what was that, 3x power 4 plus something, I don't remember clearly, that if that's a factor of that, then obviously you will get a remainder 0. And if you get a remainder p of a equal to 0, then by all means x minus a, why is this in this color? Okay, then if p of a is equal to 0, then x minus a is a factor of p of x. Okay, now by remainder theorem we know this. And now if p of a equal to 0, that is if this is equal to 0, then this equation, that is, what do we have, what is left? This is left. How can we write this? We can bring it to the denominator. P of x by x minus a gives you q of x. This you can compare it like 12 by 6 equals to 12 is p of x, 6 is, okay, this color coding is not gonna be good. Okay, 6 is x minus a, and this is this. Okay, I don't know what happened. Okay, alright, okay, and this is this. Okay, it's just that it's nothing, you don't even have to learn this. It's not gonna be it's not gonna help you, but just remember the main purpose of the factor theorem. Okay, what is the main purpose of the factor theorem? It's just a special case in the remainder theorem, and if the remainder is 0, then uh, the polynomials are the factors. That's all. That's factor theorem. Okay. Now this is just an example. Okay, about you have to check whether this is a factor. So here, there you go. Now you substitute the value of x plus 2 equals 0, then x equals minus 2. Okay, and in this polynomial you substitute that value, and then if you get 0, then if you're getting 0, then x plus 2 is definitely a factor of this polynomial. Okay, this and this are factors of each other, all right, because their remainder is a 0. Okay, now this video is going to be short because I want you to understand factorization of polynomials. Mainly I want you to understand a remainder theorem. I expect you to practice this again and again, and whatever I told to read to you initially, I expect you to read all of that. Okay, and I'll give you some time and you should be thorough, and then we'll move on to the next. Okay, this is, and from example 12 you're going to learn two methods. For a quadratic equation you're going to split the middle term, and for cubic and power 4 power 5 you're going to use the factor theorem. All right, and that's gonna be quite a bit complex if you don't know the remainder theorem and if you're not very well versed in that. Okay, so I'll give you some time and then we'll walk through this, and I want you to do only this one. Okay, I want you to solve only this for your practice. Okay, and you should not just blindly do it, you should understand the meaning. Why are you substituting x plus 1 and where x equals minus 1? Why do you do that? Ask questions to yourself, and then you will find the answers, and that will enhance your connectivity. You will establish links, and that will enhance your memory. Rather, your understanding will evolve into a higher level. Okay, that's it for today. Thanks for watching. I hope that this would be useful to you. As I said, follow my instructions and practice, and I hope you will do